What is this quantizer doing on the receiver side as the very first block? The input signal which is being received by the receiver, as we just now said, may not have the two predefined voltage levels. It might be corrupted due to the noise present in the channel. So I want my received signal to get its two original voltage levels back. In simple words, I want to assign two fixed voltage levels to my incoming signal once again. These two fixed voltage levels will be plus 5 volts and minus 5 volts. I can use 0 volts as a threshold. Anything greater than 0 should be given plus 5 volts. Anything less than 0 should be given minus 5 volts. Since I want to assign the fixed levels to my incoming signal, I can do it using a quantizer, because quantizer is used to assign the fixed levels to any discrete signal. So once I've got my two original levels back, plus 5 volts and minus 5 volts, the decoder will simply convert the digital signal into individual analog values. That means at the output of the decoder, we will have the differences available of 0.3, 0.1, minus 0.2, etc. Why do we use accumulator? For a simple reason that we had subtracted the sample values on the transmitter side. Now we have to go on adding the differences to the previous sample so that we keep on generating the original sample values. Now how will this process take place? Please remember that you can't just start transmitting the differences. We will always have to transmit the first reference sample also. So first reference sample will be given to the accumulator, that will be 4.5. The next value which will be given to the accumulator will be the next sample that was transmitted. We did not transmit the next sample, we instead of transmitted the difference, which is 0.3. So 0.3 basically gets added to 4.5, giving us the sample value of 4.8. The next output of the decoder will be the next transmitted value. After 0.3 it is 0.1, so 4.1 will get added to 0.1, and the next output of the accumulator will be 4.9. As you can see, we are trying to generate the original sample values of 4.5, 4.8, 4.9 at the output of the accumulator. The next output of the decoder will be minus 0.2, which when I add to 4.9, the sample value will be 4.7 at the output of the accumulator. So accumulator will help me to generate the original sample values, but these sample values may not be exactly same as the original values, because see, right now we did not take the correct transmitted values. We assumed 0.3, 0.1, minus 0.2 as the transmitted values, whereas we are not going to transmit these values as it is. We are going to quantize them and transmit the quantized values. So 0.3 will be assigned some fixed value and then transmitted. 0.1 will be assigned some fixed value and then transmitted. So we may not exactly have the original sample values is first thing. Second, at the output of the accumulator, for every single sampling time period, we will have some fixed value. So output of the accumulator will look like a staircase signal. Every TS, we are generating some fixed value, which is obtained by adding the difference to the previously generated value. Now just to make this signal smoother, we pass it through a filter, to be precise a low pass filter, which will remove all the high frequency components and gives us a smoother version of the original signal M of t. So that's the receiver of the differential PCM, which basically uses the accumulator, which helps us to get the original samples. Not exact values, but the values which will be close to the original sample values. That is because we are transmitting the differences which are in the quantized form, and the filter will help us to get the smoother version of the original signal back. We are calling the output signal as M cap t because it is never exactly same as M of t. Sampling and quantization are always lossy processes, so we can only generate a replica of the original signal. M cap t will be closest to M of t as long as the proper sampling theorem was satisfied during the sampling process, and during the quantization process a specific value of SNR was achieved.